Hi students, welcome to the light. Once again, today we will be discussing a very important topic and a very interesting topic. Okay, and the topic is trigonometry. Yes, so today we will be discussing about trigonometry part. Okay, so now what is the trigonometry? Now this trigonometry is nothing but a three-sided figure, right? So now if you just see here, trig, which is nothing but 3, and a trigonometry, which is nothing but a geometry. So anything which is a three-sided figure, we call it as a trigonometry. But three-sided figure, we know that it's a triangle, right? But in the trigonometry part, we will be discussing exclusively about a right angle triangle. Yes, so we will be discussing exclusively about a right angle triangle, and we all know there are different types of triangles, right? Equilateral, isosceles, scalene, right angle triangle. But trigonometry concentrates mainly on right angle triangle. Okay, now in right angle triangle, now if I just take this right angle triangle, okay, now we'll name it as A, B, C, and this is a right angle triangle. Now in the right angle triangle, what we should know what is what, right? Now we all know the basics very much. This is a base and this is a height, and this is a hypotenuse, right? Are you clear with this? I mean, everyone will be knowing this as a part of basics. Now in trigonometry, if you have really learnt in your previous classes, there is something called as Pythagoras theorem. So we'll be coming to the Pythagoras theorem in next session. Now, where do we see this right angle triangle generally? Now imagine a very classic example. A person standing with a happy face and now is staring to a electric pole. Okay, he's standing on the ground and is staring on a electric pole. He's staring to the peak, that means a last point of the electric pole. Now if I consider this as a horizontal line, now can you able to see a right angle triangle over here? Yes, this is a right angle triangle which you will be seeing. Okay, look here, a right angle triangle of 90-degree has been formed. Generally you could see all these examples, a person staring at a cliff and all those examples. So but one of such a classic example is just a person seeing an electric pole to the top of a electric pole. Okay, so are you just clear with these basics, like how the 90-degree triangle and what are the things, and we shall just discuss later like how the angles, about the angles, and the trigonometric functions. Now moving on to the next thing, which is called as trigonometric functions. A very important one, this trigonometric functions. And from now onwards, we will be discussing about angles. Now suppose if this is a right angle triangle, there will be an angle, right? A, B, C. Now angle B, angle A. Now from now onwards, in trigonometry, we will be pronouncing any angle in terms of theta. Yes, theta are very important. Okay, Now, in trigonometry, there is something called as trigonometric ratios, right? So we call it as a trigonometric ratios. Now, trigonometric ratios or functions. Now, generally, we have 6 trigonometric ratios. Okay, so how many? 6. Now, what are the 6 trigonometric ratios of functions? We'll just see now. Now, suppose if this is a right angle triangle, I'll just name it as a theta. There is an angle called as theta. Now, if I name this triangle as A, B, C. Now, in triangle ABC, there is an angle which is called as theta, and any side which is opposite to that angle, we call it as a opposite side. Okay, and anything which is adjacent to that angle, we call it as a adjacent side. Okay, and we all know that this is an hypotenuse. Now, if you just clearly observe over here, now this adjacent side, right? This adjacent side is nothing but a base of the triangle ABC, and the opposite. So this opposite side is nothing but a height, and adjacent is nothing but a base and generally hypotenuse. Now, because why I am telling this height and base concept is, suppose if there are questions like suddenly, if the base of the triangle is so much and the height is so much, so you need to find out the trigonometric identity. So there are lot many problems which might arise in the upcoming topic of in the upcoming part. So that is why I'm just letting you know what are the other terminologies you can name it. Okay, now coming back, suppose in this triangle ABC, A, B, C, 90 degree, and there is an angle theta, and we all knew that now this is an opposite side and this is a adjacent side. This is a hypotenuse, right? Now, what are these trigonometric functions or ratios we have? First, we shall discuss about sine. Now, what is the first trigonometric ratio or the function we'll be discussing is sine of angle B, or which is nothing but theta. So simply we can write it as sine theta. This is the shortest form what we can name it for sine theta. Okay, now what is the definition of this sine theta? Please make sure you need not to write the full form SINE sine, so you can also name it as a sine sine theta. Okay, even in this form as well. Now, what is the sine theta? Sine theta is nothing but opposite side of the angle theta. Opposite side of theta by hypotenuse. So I'm just repeating it. Opposite side of an angle theta by hypotenuse. Now what is the opposite side? AC by hypotenuse is AB. Simple. This is sine theta. So the very first function, it is sine of angle theta, or you can simply write it as sine theta. Is nothing but opposite side of the angle theta by hypotenuse. Clear? Now what's the next angle? What's the next function? I'll be writing it again and again, not an issue. It just didn't go well. Now triangle ABC, and this is a theta A B C 90 degrees. Now this is opposite, okay, and this is an adjacent, and this is an hypotenuse. Okay, now what is the second function or the second ratio? Is cosine of angle theta. Now once again I'm telling you, instead of writing cosine of theta, the short form what you can use for this is cos theta. Okay, so what you can use instead of cosine of theta, you can just simply use it as cos theta. Okay, now what is this cos theta? Definition of cos theta: it is adjacent side of angle theta. Adjacent side of angle theta by hypotenuse. So what is the definition? Adjacent side of theta by hypotenuse. Now what is the adjacent side of theta? Come on, simple, BC by AB. So this is your cos theta. The definition. Simple, very simple. Please make sure you get these definitions very right. Okay, now one of the catches here, if you are able to remember sine, cos, or sine of theta, cosine of theta, rest all the trigonometric ratios of function you can just do it without any triangle or writing the sketches. Without this you can easily make it out. Now how is it? Now I'll not be writing the diagram. Okay, I'll just show you. Now the third function is, tangent of theta. Okay, now what is the third function? It is a tangent of theta, or simply in a short form, tan theta. Simple, it's just as simple as that. It is tan theta. Now what is this definition of tan theta? If you write it in form of a rectangle, okay, this is theta, right? This is A, B, C. It is opposite by adjacent. Opposite by adjacent. So what is opposite of angle theta by adjacent of angle theta? So this is one of the definition of tan theta. Now if you just remember just now what we have discussed, sine theta, opposite by hypotenuse. Now I shall just do it now for this. Now we just came to know that tan theta is nothing but opposite by adjacent, isn't it? Now what is sine? Opposite by hypotenuse. And what is cos theta? adjacent by hypotenuse. Now if you're gonna see, if I'm gonna divide sine theta by cos theta, opposite by hypotenuse whole divided by adjacent by hypotenuse, this hypotenuse cancels out. What will we remember? What will be having? It is opposite by adjacent, which is once again nothing but tan theta, right? Just have a look here, right? Now by this what we can conclude? So tan theta is nothing but the ratio of sine theta by cos theta. As I said, if you just know sine and cos, it is very easy to find rest all. So you got your tan theta now. Is it that simple? So as I said, please make sure you follow the basics. And now once you're learning this, you should gonna learn it with 100%, guys, because the rest of the sums, so on the next sessions we'll be discussing the applications of these things. So these trigonometric ratios are very, very important. I'm telling you, it's damn important. Now the fourth part, which is the fourth trigonometric function, what we'll be discussing is cosecant. Now come on, what is it? Cosecant of theta. Now what is this cosecant? Or in a simple form, once again the short form, cosec. Okay, so cosec theta is nothing but, so cosec theta is nothing but, now what is the definition is hypotenuse by opposite of theta. Now once again, opposite by hypotenuse, you know the definition, right? So opposite by hypotenuse is the definition of sine theta. Exactly. Now never forget these things. Look, now sine theta is nothing but opposite by hypotenuse, but here what do we have is hypotenuse by opposite, which is nothing but a ulta or the reverse of sine theta. So therefore cosec theta is nothing but 1 by sine theta. Easy, very easy. Look, it's that simple. We just finished the 4 of the trigonometric ratios very fastly. Now the fifth one is secant theta. Secant of theta. Now what is this secant of theta? And once again, please feel free to use the short forms, which is nothing but secant theta, sec theta. Now what is the definition of this? Hypotenuse by adjacent of theta. Come on guys, now I think you should, I know you have already got the answer. What is the definition of cos theta now? Adjacent by hypotenuse. Now here it is ulta, so which is nothing but 1 by cos theta. Simple. So therefore secant theta is nothing but 1 by cos theta. Very, very simple, isn't it? Now come on, the last thing, the last trigonometric ratios you need to know is cotangent of theta. Now come on guys, the name itself suggests you have learned about tangent. Now what you are learning about is cotangent, so obviously which has to be the ulta or the reverse of tangent. And once again, please feel free to use the short form cot theta. I just need cot, I don't want cot tan or cotan, something like that, so you can just pronounce it as cot theta. Okay, which is nothing but adjacent of theta by opposite of theta, or simply we can write it as 1 by tan theta, right? Or cot theta can also be written as cos theta by sin theta. Remember what is tan theta? Sin by cos. But what is cot now? It is a reverse, which is nothing but cos by sin. Simple. So this is end of the session 1, and in our next session we will be discussing the problems regarding to this. What are the applications we can the problems, how we can solve, what are the different types of challenges we'll be coming across with these things. Okay, so this is the end of session 1. So please make sure you like the channel, you subscribe it, and press the bell button icon for every new video so that you'll be notified first. And make sure please leave a comment about the session so that I feel like like giving more onto it. Okay, and make sure you please share it among to your friends, and make sure you're spreading the light of enlightenment, and as well as which helps even to me to make something more and energetic. Okay, thank you so much, have a great time.